Hello everyone. This is a podcast Artificial Conversations, episode 17. I'm Mika, and on our side of the earth in Germany, my friend Tuxifan.
Hello.
This is going to be an experiment. We are going to record it normally, then process it through speech to text, and regenerate it using text to speech. I'm hoping this will reduce the amount of editing because if I record normally, it takes about 1 to 5 hours of editing. If it's 1 hour of recording, it's 5 hours of editing. That's a lot of time, and I don't have 5 hours. Hopefully, this approach will significantly reduce the editing time. I'm located in Southern California in the United States, and I'm a software engineer working in an AA game studio right now. Can you tell a little bit about yourself?
Yeah, I'm Njords. I'm from Hamburg, and I've been living here my whole life. I'm currently learning software development, and I'll hopefully get a good job next year.
Are you learning by yourself or in a school?
It's a type of education. There isn't a real English translation for it because it doesn't exist in English-speaking countries. Basically, it's like school but specialized for teaching specific jobs. So it's part-time school and part-time job.
In Russia, we have something similar that we call college, but it's not a bachelor's or master's degree. You get a document that qualifies you for a specific job, like a craft job. Back in my day in Russia, we didn't have computer science jobs. It was mostly vocational training, like learning welding or sewing.
In school, we cover all the theoretical aspects, like learning data protection laws, and then we learn the practical stuff on the job.
So the job is more like an internship, right?
Kind of, but it's better paid. Internships in Germany typically aren't paid, they're done for free. Germany is one of the few countries that does this. That's why I've never done an internship here.
Oh, it's free labor. You worked for an AI company located in New York, but you were working remotely, right?
Yeah, that was Mika AI. They're developing a chat inference GUI for language model inference called GPT-4all. They used to only run on CPU, not GPU. They couldn't implement GPU without getting a proper license for CUDA because you're not supposed to just include CUDA in your projects without asking NVIDIA. Most projects do that, but it's not the right way to go about it.
Right. Oh well, I didn't know they have such strict licensing.
I was tasked with implementing LLMA in the GPU using Vulkan and GLSL. Yeah, that took me about 5 weeks, including cleanup. Now it's merged and works somewhat. It's typically not really faster than the CPU, but at least it doesn't use a lot of CPU power.
There are different types of compute engines. I've heard of CUDA.
We ended up using a library called Vulkan Compute.
Vulkan Compute.
Yeah, it works even on a phone. You could practically run this on a mobile phone. I think it works on devices with a 1.2 version.
Recently, I've been experimenting a lot with LLMA, CPP, and using CUDA with it. I noticed it has a lot of different types of compute engines, like Vulkan.
Yeah, we used LLMA. CPP is the backend. If you've seen a Vulkan backend in LLMA, CPP, that implementation was written by me.
Oh, it's yours? I tried to get it working, but I kept forgetting which version to use since I have 2G plus one is 7.6 and the other is 8.5. I was trying to make Whisper work and compiled it with different parameters, but it didn't work. I thought I'd try the Vulkan one, but that didn't work either. In the end, I got it to work with normal CUDA.
There's an interesting project now that implements the whole CUDA toolchain in a way that is compatible with AMD. It includes the compiler frontend, so you can just pass it as the CUDA path when compiling applications, and it compiles the CUDA code for the AMD GPU. Unfortunately, that is proprietary.
I'm wondering, you're quite experienced in software engineering already. Why do you need to go to school? You could just start applying for jobs.
The big problem is that after finishing, you get a certificate. If you don't have that certificate, companies are just going to refuse to pay you a higher salary. So I wouldn't be paid well.
I see. So you're just trying to navigate the system to get a higher salary. That makes sense. You just want to get that piece of paper.
Yeah, that's all.
How long will you be studying?
I started 3 years ago, and I'm going to finish next summer.
Okay, and you've had some internships.
Yeah, the next one is going to be in Switzerland if everything works out right.
Are you planning to focus your career on AI and large language models?
Not really. AI is interesting, but it's not my main focus. My biggest interest is definitely in embedded electronics like microcontrollers.
There are many areas where you can implement it. How low level are you looking at? Is it Raspberry Pi level, Arduino level, or even lower?
The microcontrollers I typically work on don't have user space, so it's more like Arduino. I've also been working with FPGAs.
With FPGAs, you can't really program in high-level languages, can you? Is that a visual language?
Not really. There are some visual languages for it, but the main language I use is called Verilog. No, if you want to run high-level code on an FPGA, you first need to implement a CPU on it, and then you can run high-level code. FPGAs are mostly meant for low-latency signal processing.
I kind of remember that. Engineers I worked with used a visual language to design chips, then burned those designs onto the chip. Essentially, they created the CPU using a visual language and then wrote code using assembly.
Yes, that sounds accurate.
So you're interested in very low-level embedded systems?
Yes.
That means...
The interesting thing about FPGA languages like Verilog is that many rules you learn in higher-level programming languages, like C, simply don't apply. For example, in C, your code runs from top to bottom. In FPGA programming, all lines of code run at the same time, which introduces some interesting challenges.
Yes, you can make it run in parallel.
It really takes some getting used to.
I think of it as optimizing a function that takes a set number of bits and generates an output. You essentially need to put the function in a black box that performs the processing. The FPGA compiler optimizes this because you can specify inputs and desired outputs, and it creates an optimized black box that processes them quickly by parallelizing operations.
It's not that simple though. There's clock programming and clockless programming. In clockless programming, if you have two inputs, and B, and one output C, you can simply say C equals a plus B. However, you can't do multiplications this way because they require iterating over the same number multiple times. For multiplications, you need clock programming, where you take two inputs.
I think you can still do multiplication, right?
You can, but it wastes a lot of space.
Right, like with 2-bit by 2-bit multiplication or 4-bit by 4-bit. It seems like you could use a lookup table for optimization.
Yes, you could do that, but you would typically do this with hardware programming. For example, you have an input A, an input B, and an enable input, which is just a single bit. From one module that uses this multiplication module, you would set it in B, raise the enable line, and start processing, adding one number per clock cycle. Finally, you enable an output line called ready, and the other module will see that the result is ready. It gets complicated very quickly.
Yeah, or you can just have a CPU without multiplication at all and make programmers implement it.
Actually, one of the microcontrollers I use doesn't have multiplication or division. You have to implement runtime functions for those, which waste about 20% of your flash storage.
Just for multiplication. I was interested in RISC-V architecture. I wanted to create a virtual machine that could run efficiently, allowing players to program logic in a game.
Oh yeah. I've actually written a compact RISC-V interpreter that you could probably use.
The challenge is figuring out the gameplay and making it appealing for players. It involves real programming and debugging, not simplified mechanics. For example, in games, you might say, move the square to that square, but hacking for real is more complicated. If you're programming in a real language and it doesn't work, you need to pull up a debugger. Essentially, I need to integrate an IDE into the game and make it appealing for players. I feel stuck on the game design part, and I see it as a first step toward creating a real metaverse. Many companies are trying to bring the metaverse idea to life.
It's an interesting concept.
In my mind, it's like YouTube for games. For example, Mark Zuckerberg envisions it as games for socializing, but I see it as a platform that allows people to easily create and publish games, just like how anyone can make a YouTube video with a smartphone and share it.
That reminds me of a project called Resonate. It's a visual programming language that lets you script things in your world and invite others to play the games you've created. You might find it inspiring.
Yeah, companies are trying to make the metaverse a reality. One of the most successful is Roblox, using Lua as their scripting language. Epic Games is also pushing a Fortnite editor and has developed a scripting language called Verse. They're not hiding their intentions to create a metaverse. Meta is also heavily investing in this direction.
Okay, interesting. I thought they had given up on the metaverse.
No, they renamed the company and are investing a lot of money into it. They released the next revision of the Oculus Quest and are committing significant resources to it. What else can they do? **** vision, it's more about social interaction, wanting to create social games. The Horizon platform doesn't look very good right now, it's quite basic.
Aren't they also pushing for virtual workplaces?
Yes, it's not just about games, it's also about social and business interactions in a virtual environment. However, I think there's a high barrier to entry for the metaverse since you need to learn specific scripting languages. In Roblox, it's Lua. In Fortnite, it's Verse. For Oculus Quest, you need a more complicated setup, including an Android SDK and high-level programming languages. My idea is to create a virtual machine that supports any language, allowing users to compile and run code with a lightweight API for communication with the game world. I believe this is a better approach. Do you remember I was working on a project codenamed Mika? The programming for it was in JavaScript. It was my first iteration, but I realized the V8 engine is broken. It does a good job of fixing JavaScript and WebAssembly issues, but why not just pick the best tools from the start? I realized that RISC-V architecture could be a good candidate for a virtual machine.
That sounds like a use case for WebAssembly. There are other WebAssembly runtimes as well. There's a very lightweight WebAssembly engine written in C with C++ bindings that I've been using. I've run it on an RP2040 microcontroller.
What's the point of trying to fix something that's already broken like JavaScript?
You don't have to use JavaScript at all.
I thought of WebAssembly as an extension of JavaScript with garbage collection and the synchronous capabilities.
The standalone WASM engines interface with C++ instead of JavaScript.
So you think WebAssembly is a better candidate to be the back end of a game engine?
Yes, very likely. Hold on, I'll send you a link. It's called WASM 3.
With RISC-V, I made quite a bit of progress. I found a VM within a MIDI license and played around with it. I think last year I created a short video where I managed to run Linux inside a virtual machine in the game engine, and it was running RISC-V. I used two emulators for that.
Yeah, I remember that. Which emulator did you use?
Gmark? No, it was TinyEmu.
Oh, okay.
TinyEmu was running Linux, and I implemented Forklift, which had a different emulator. In TinyEmu, I used full Linux compiled things and wrote the driver for the hard disk. I could pretend to inject the USB disk, copy binaries to it, and then use the USB disk in Forklift. Forklift didn't run Linux, it was just bare metal.
Oh, okay.
This was my effort to figure out how to make the game, but I realized I got stuck not on technical issues but mainly on game design challenges.
Yeah. I think WebAssembly is probably the better choice here because it's meant for embedding code from various languages safely.
I was playing around with the V8 engine, and the problem was the state of the VM. I wanted to copy the VM state between the client and server, but sometimes it's just so much data.
Yeah, because you've got all the stuff in between, right?
With RISC-V, if I create a bare metal one, it might be just several kilobytes of data. I wanted to run game simulations simultaneously in the server and client, periodically checking for sync. If they get out of sync, the server would say, "Here's my state, start from there to reduce latency." I was deploying a server in Dubai, which meant a really long latency. If you're constantly pulling the state from the server, it's very noticeable and creates a poor player experience. If the client runs the whole world simulation and just gets periodic updates from the server, it can do speculative calculations. If the client thinks a player moved in one direction but the server disagrees, it can reset the state and re-simulate. I was trying to reduce the latency issue and synchronize the V8 state between the server and client, which was quite a nightmare.
Yeah, I can imagine. In WASM 3, you specify how much RAM the virtual machine will have. For example, 1 kilobyte is usually enough for tiny programs. You can easily modify the C code for this. It's pretty simple.
Yeah. The interesting thing is, it's like Emscripten. You build the code in Emscripten and then put it in your VM. Another challenge is bringing the toolchain to the end user.
The way I did it was by writing a tiny CMake file that invoked the compiler with the correct flags to build for WebAssembly.
I'm talking about allowing players to write code in a language of their choice, which needs to be compiled somewhere. There are a couple of ways to do this. For the laptop project, I used TinyEmu with a packaged Linux. Another option is to allow players to upload source code to the cloud, which would generate the binary.
Yeah, people have compiled a version of Clang for WebAssembly, so you could technically integrate it into the game.
Just like putting Linux in the game.
Yes, but there's a licensing problem because Linux is GPL, so you need to navigate those licenses.
Right. If you provide the VM and the ISO, you might just need to provide the source code that creates the ISO since there's no linking involved. It's just the ISO running inside the VM.
Exactly. Many Android phone manufacturers provide Linux kernel code downloads on their websites. One of the routers I bought, a common brand in Germany called Fritzburgs, even included the GPL license in a tiny booklet that came with the router.
That's good. At least it's not a lot of text. */*. It looks like you're not very excited about RISC-V.
On the contrary, I am excited. The microcontrollers I use run on RISC-V.
Oh, not as an emulator, but as real devices.
Yes, they're actual RISC-V microcontrollers. The tiniest microcontroller I've worked with runs at about 0.7 MHz, has 2 KB of RAM and 16 KB of flash memory. That gives you an idea of the constraints I'm working with.
So, do you have any practical applications for that microcontroller?
I'm trying to build a calculator with a tiny display and some buttons. It's supposed to run off a coin cell battery, which I know is possible.
A coin cell battery, got it.
I might also incorporate a solar cell, but I'm not very confident in my electrical engineering skills.
What programming language are you considering for the calculator's end users?
Just a simple digit input, nothing too exciting.
Not even a smart calculator. I thought you might be aiming for graphing calculator.
I've been experimenting with implementing a compiler on the microcontroller for a tiny custom language. It's not easy because implementing a compiler usually involves creating an intermediate representation that compiles to native code. How familiar are you with that?
I know about assembly, yes.
Okay, so you know that the intermediate representation IR can be quite complicated in terms of data structure.
What makes the IR complicated?
The IR is typically complex because it serves as a bridge between high-level code and the native code.
Are you talking about the multiple steps involved, like creating an abstract syntax tree ASD? Is it the same thing?
The idea of intermediate representation IR is...
Where is IR just assembly? There are so many layers in the compiler, right? The compiler creates the abstract syntax tree ASD, which then generates assembly code, and the assembly code gets compiled to opcode. Sometimes there's an intermediate level that Cling uses, right? It generates another assembly code, which is then compiled to opcode.
Exactly, that's the idea behind IR. It simplifies the compiler because it's easier to perform certain optimizations there. For example, with dev code optimization, once you've generated the assembly, it's hard to identify which instructions are used. In IR, you can see instructions that use the results of others. If an instruction has 0 users, you know it's irrelevant and can be deleted.
Yeah.
At the IR stage, the concept of CPU registers doesn't exist yet.
Creating a proper compiler is complicated with many steps, but if you just want one that works, it's not too hard. I assume you're using C for the compiler on the microcontroller, not C++.
Yes, just C with a custom standard library.
C is quite powerful for building a simple ad hoc compiler. The hardest part is parsing the code. After that, it's mostly straightforward. If you don't want to optimize, it becomes simpler. Of course, complexity arises if you want to reduce memory usage or improve speed. Alternatively, you could create an interpreter, which I think is even easier.
Writing an interpreter might be boring though. I'm trying to learn something, and if I just write an interpreter, it wouldn't be challenging.
I see your point.
Memory-wise, this microcontroller has 2 KB of RAM. The compiler currently uses about 600 bytes a peak.
2 kilobytes.
Yes, no heap, just stack. I implemented a heap, but I'm not using it.
2 kilobytes is very limited. You could just add more RAM like 16 KB.
This is hard. Laughs. But it only requires 1 milliamp.
I see.
The reason I chose this chip is for its efficiency, not its power.
So you're looking for a small battery, like a CMOS battery?
Yes.
Have you been playing with LLM and AI, like LLMA or NOPM?
Not so much. I've mostly been exploring audio processing eyes. I think that's very interesting. I'm not deeply into how it all works. I just look for new projects and hope to find something interesting among them.
There are quite a few tools out there for text-to-speech, speech-to-text, music generation, AI-powered mastering tools, and pitch correction. What kind of audio processing are you exploring?
I've recently been playing around with FA codec, specifically FA codec 3. It has an interesting feature where you can upload your voice in another voice, and it tries to change your voice into that other voice. It works like a voice changer, but not in real time.
A mempemba voice changer, yeah.
It's pretty fun, but it doesn't work perfectly.
With this podcast, I'm aiming to create a voice changer, but it's not a traditional one. I'm focusing on transcribing to text, and then using text to speech.
Yes, I'm mostly interested in text-to-speech and speech-to-speech.
So voice changer, essentially. I was playing around with a voice changer for my games because I want to include voice acting, but I don't have the budget to hire voice actors. I thought I could just use my own voice with a voice changer, but the results weren't very satisfactory.
The biggest issue I've encountered with FA Codec is that it doesn't handle accents very well.
Yeah, with my voice changer, it exaggerated my accent. My Russian accent is noticeable but not heavy, and when I applied the voice changer, it made it sound like a really heavy Russian accent.
For me, it just distorted my voice completely. It didn't make sense anymore.
I don't think you have a strong accent at all. I wouldn't even notice it unless I knew you were German.
Okay, well.
I was trying to continue with text-to-speech. There are plenty of text-to-speech tools, but most are in Python, and there aren't many libraries. Right now, I'm running a Python process and doing IPC communication with my C++ code to get the audio.
That sounds good.
So, what's your approach?
Typically, I use PyBind11, which allows me to call Python code from within C++. It usually works quite well.
Yes, can you repeat that Python library?
It's PyBind11.
I've never heard of it. I might try it out.
It's pretty cool. It's primarily meant for writing Python bindings for your C++ code so you can import your C++ library into Python.
But it works in the opposite direction as well. I can't program in Python, I've tried, but dynamic typing is challenging for me, especially when running a long test suite. After 30 minutes, discovering there's a typo in a variable name is so discouraging.
Yeah, I don't like dynamic languages for the same reason. It's hard to debug code that you haven't written when you don't know what type something is going to be.
Exactly.
For example, you have a variable and you see that it's being added to something else somewhere. You might wonder, what is it? Is this a string or an integer?
Right, and the type can change because it's mutable. Someone might assign a different value to it, and then you're left trying to figure out what type it is.
Debugging can be pretty annoying as well because Python is garbage collected. If the Python runtime decides to get rid of the variable, but you're still debugging, you might want to see what it is. The runtime might just say, I can't show you because it's already been garbage collected.
I think in C++, especially with optimized code, you often find that you can't show certain variables because they were optimized away.
Yes, but you can switch to debug mode in that case. Disabling the garbage collector in a language that relies on it is a nightmare.
In Unreal Engine, the garbage collector is even worse because you have to tell it not to collect certain objects that are still in use. If you use C++ data structures and put a pointer inside a vector, map, or set, Unreal Engine doesn't know it's there. The garbage collector runs infrequently, which can lead to crashes after a few minutes of working fine.
I see. You know what Unity does. Unity has this IL2ZBB feature that translates C# to C++. But since C# needs a garbage collector, they use something called BoneGC.
Yes.
BoneGC literally scans your entire stack and heap to figure out which pointers are still in use.
That sounds slow.
It is. It's common to experience noticeable stuttering in Unity games due to the garbage collector, which you have to manage carefully.
Interesting. Is that a real issue?
They've optimized it quite a bit, but it still has its challenges.
I think using a virtual machine in Unity was a good idea, but choosing the init EVM was not the best decision.
They use Net, specifically Mono. I believe they forked the Mono project to implement their improvement. It's not the same as Microsoft Net.
Right. Microsoft went through the trouble of standardizing that.
Yes.
So, it seems similar, but I haven't followed the details closely.
There used to be something called Managed C++ about 10 years ago. It was a C++ to C# compiler that Microsoft created, combining C++ with garbage collection within a C# environment like Mono or Net, but it didn't really take off.
Yes, I do remember this. At Technicolor, I worked on a project involving disparity map calculation, which is used for stereo video. There's an algorithm that calculates the z-coordinates of pixels based on their shift due to parallax. This project was written in ET but used C++, so we faced quite a few challenges because C++ was not the primary language in that infrastructure.
Sorry, my phone just rang. Let me put it away.
I haven't heard that cell phone interference sound in a long time. Modern smartphones handle that pretty well.
Yeah, I remember my aunt had my phone next to her alarm clock. It changed some settings, and the next morning I woke up at 2 a.m. instead of 5 a.m.
Laughs. That's hilarious.
The backlight turned on when she received a call.
Oh my god. So you were essentially microwaving yourself with a cell phone.
Laughs.
I used to hear that GSM interference sound all the time, but I haven't heard it in ages. About languages, I find it interesting how much it matters when you learn a language.
Yes, even if you live in a country where a language you learned early on isn't spoken, as long as you keep using it, you can become very proficient.
Yes.
Also, pronunciation plays a huge role.
Yes, the accent.
In Germany, the way you use your tongue is quite different from English. You might try to use the same movement, but they don't connect properly, which can lead to an accent.
In some languages, certain sounds just don't exist and your brain doesn't distinguish between them. For example, with least and list, I can understand the difference based on context, but I can't hear the difference in sound.
Oh, is there a difference?
Yes, there's a slight difference, but it's subtle. I think when you say least, your tongue is positioned deeper in your throat than when you say list.
Oh yeah, that makes sense. You don't realize those nuances unless you think about them.
Yeah, and also flash and flush. I don't even know how to spell these two words properly.
Flash and flush?
Yes, like a flashlight or flushing a toilet.
That's why I pronounce it flash with you, because it's easier to distinguish.
Lath.
Do you pronounce it differently where you live? Are you saying flesh because you can't pronounce the A, or is it just a regional thing?
It's the same sound for me, I don't hear the difference.
Interesting.
Flash and flush sound the same to me. Laughs.
Yeah, that's odd. I have my microphone in monitor mode so I can hear myself better, but my stomach just rumbled.
Laths. So, have you been playing with Whisper lately? I'm planning to use Whisper for transcription.
Yes, Whisper CPP is pretty cool.
It's interesting how it picks up various noises. It's not just transcribing speech, but it recognizes sounds like laughter.
Oh yeah, it depends on the language. In German, Whisper doesn't work as well. But in English, it's quite good.
It understands me, which is good enough. Laughs. I was trying to transcribe my previous podcast with my friend Andres, who's also Russian. It took a long time to get Whisper to transcribe it as English. Every line was marked as foreign language, even though he was speaking English. His accent made it hard for Whisper to recognize.
Oh no, that sounds frustrating.
Welcome back.
I didn't leave, it just cut out on its own.
I think we hit the 1 hour mark. It's a good reminder. My connection might not be great. Testing. 1, 2, 3. Is it better now? I think we can wrap up now. It's been about 1 hour and 10 minutes. So yeah, time flies, right? Thank you for listening to our experimental podcast, everyone. I think laughs. I guess we'll wrap up our conversation. It was nice talking to you, Tuxifan. Yes, talk to you later, bye. Laughs.